So in this lecture, we're going to look at 3 examples of redox reactions, and we're going to assign oxidation states to each atom in our molecule. So let's begin with the first one. So we begin with copper in its elemental state, and that means copper gets a charge of 0 according to our rules. Let's look at nitric acid. Now nitric acid contains an H and an N and an O. That means we first assign to H, then we assign to O, then we assign to the N. Now our entire molecule must be neutral, so we must take that into consideration when assigning. So let's give our H a +1 according to our table, and let's give an O a -2 according to our table. So our N should be a number such that when you add that number to 1 and when you subtract -6, we get 0. Why -6? Well, because there are 3 oxygen molecules. So 3 times -2 gives us a total of -6. So -6 plus 1 gives us a 5. So our N should be 5. Let's check. 1 plus 5, 6. Minus 6 gives us a 0. So that works. Let's go to this side. So here we have copper nitrate. So from this part, we know that N and O3 is a -1, right? Because the entire thing, to balance a neutral charge, this must be a +1. So this guy is -1. So our NO3 is -1. So NO3 is -1 times 2 such molecules. This whole thing means it's -2. So our copper must be +2. So our copper is +2. Now that means our oxygen is -2, and our N must be +5. So this whole thing must be -2, including this 2 here. So let's go to nitric oxide. So our O, we first assign our oxidation state to O. And our O gets a -2. So that means our N must be +2. Why is it +2? Well, because this molecule is neutral. And that means charge of 0. So to balance this -2, this N must be a +2. And finally, let's look at water. Water, the oxygen, well, we first assign to our H. So that gets a +1. +1 times 2 gives us a +2. So this guy must be a -2 to balance out the neutral charge. So now let's look at what gets oxidized and what gets reduced. So our copper goes from a 0 charge to a +2 charge. And that means copper is oxidized because electrons are removed, and these electrons transfer to some other atom. So let's look at what atom is reduced. So our N goes from a +5 to a +2. That means all the electrons move from copper to N, creating that +2 charge. So our N is what's reduced. So our oxidizing agent is this guy, nitric acid, the N specifically, and our reducing agent is copper. So let's write that. So this guy is so it's oxidized. And this guy is reduced. Okay? And once again, our reducing agent, our oxidizing agent. So let's move on to example 2. Now in example 2, we begin with copper sulfide, so an oxygen in its elemental state. So oxygen automatically gets a charge of 0 because it's in its elemental state. And let's look at these guys. First, we assign our charge to our sulfur. Now, sulfur is in the same group as oxygen, and that means it gets a -2 charge. So our sulfur is -2. Now, to balance this guy off, because this entire molecule is neutral, a charge of 0, our copper must be a +1, because we have 2 copper molecules, so +1. Let's check. 2 times 1, 2, minus 2, 0, works. So we're done with our reactant side. Let's go to the product side. So now copper is in our elemental state. So our copper must be neutral, 0. And let's look at SO2. So oxygen gets assigned first. So oxygen gets a -2. A -2 times 2 is -4. So what must S be? Well, if this whole thing is neutral, this guy must be +4. Why? Well, because +4 minus 4, -2 times 2, gives us 0. So let's see what's reduced and what's oxidized. Our oxygen goes from 0 to -2. And that means this guy is reduced. So let's write this. So it's reduced. Our oxygen is reduced. So what gets oxidized? If something is reduced, something must be oxidized. So our copper goes from a +1 to 0. And that means actually copper also gets reduced. And so copper is actually also reduced. So let's write reduced for our copper. Now sulfur goes from -2 to +4. That means our sulfur is the atom that gets oxidized. So let's write that. So this guy gets oxidized. So 2 atoms get reduced, 1 atom gets oxidized. So this guy, that means this guy is our reducing agent, while our oxygen must be the oxidizing agent because it obtains those electrons. It takes those electrons away from the sulfur atom. So let's look at our final example. So zinc sulfide plus oxygen gives us this guy. So our oxygen, once again, is in its elemental state. So our oxygen gets a charge of 0, a neutral charge. Let's look at these guys. So we assign our charge to sulfur first. So sulfur gets a charge of -2 because it's in the same group as oxygen. So this guy gets a -2. And our zinc must have a charge of +2. So +2 minus 2 gives us neutral. Makes sense. Let's go to this guy. So first we assign our charge to oxygen. Oxygen gets a charge of -2. So this guy gets a charge of -2. Now our zinc stays at +2. So zinc remains at +2. So in order for this whole molecule to have a charge of 0, that means all these guys must add up to 0. So -2 times 8 times 4 gives us -8, plus 2 gives us -6. So our sulfur must have a +6 charge. So what's oxidized, what's reduced? Well, our oxygen goes from 0 to -2, so that means oxygen gets reduced. Okay. Now our sulfur goes from -2 to +6, and that means our sulfur gets oxidized. So our sulfur gets oxidized. So whatever gets reduced is the oxidizing agent because it takes electrons away from that atom, specifically the S atom. So this is our oxidizing agent. And this guy is our reducing agent